So thank you for the introduction, and also thank you for the opportunity to be here, and also the invitation to know all of you and try to provide more information about what we are doing from BSc, but also from this Center of Excellence. So I'm really happy to be here. And I'm Mario Acosta. Coming from this Barcelona Supercomputing Center, as you know, we are doing everything. But in my case, working in the Earth Science department. No. From this specific department, what we are doing is try to focus in the environmental modeling part, forecasting, air quality, weather and climate prediction. Also, we are really connecting to this idea about create an impact. So this means that try to support the society, try to participate in these environment challenges through some service and development. Now we are close to, actually it's more than 230 people. And yes, we are mainly funded by the European program, this Horizon, Copernicus. We are one of the main partners of the Climate Digital Twin in the Destination Earth, and then also national and government. From this one, I am leading this one. And was curious because I provided this information just a couple of months ago, but now my group is not 70 anymore, and we are 80. So we are growing too much, actually. So the topics now that I would like to introduce you, apart from the Center of Excellence or the specific research in which we are working, is why this HPC. I'm talking here about exascale machine, also with a very huge computational capacity that we need to run our ocean and climate models. Probably some of you know very well this information, no? But the idea, we increase the complexity of this Earth system model that we are using from the 60 with our nice Fortran, and we are increasing more and more the component that we are using, no, for this Earth system global modeling simulation. So it's not just ocean atmosphere anymore. We are talking about the chemistry, the vegetation, the land surface, different component that must be there in parallel running with the other component, which means also more computational power and more complexity. Then also, as you know, we are talking about chaotic models, which means that also we cannot just run one simulation, but we need the ensembles, which means that in Mare Nostrum, for example, we need to maybe run 50 times whatever that we are doing, no, to ensure the accuracy of the model, and also that we are reproducing something that makes sense, no, for the climate studies. And then in my department in particular, we are more focusing in the prediction and projection. So means that we need to run 50, 100 years of the simulation. Actually, just right now, the climate scenarios that we are doing for Destination Earth, we are simulating 50 years, and this means that we need Mare Nostrum 5 with a very big capacity of Mare Nostrum 5 running 90 days to facilitate these climate studies of 20 years. So it's a very big portion, no, that we need to simulate this. And of course, the resolution. This is a real simulation that we did it, I think was 4 months ago, using this global Earth system model with the 1.25 kilometers for NEMO plus IFS. No? So this is part of the ocean model, but also was running in couple with the IFS. You can see here just some example about the simulation, but obviously the future, for example, vorticity, no, that we can see with this global Earth system simulation at this resolution is something that was not possible with the typical CMIP, no, or the experiment that we were doing with the also more traditional resolution as 150 kilometers, 20 kilometers, no? So what we are able to do now with this new experiment that we are doing for the Climate Digital Twin, Destination Earth, and with the supporting of the Center of Excellence as ESiWACE, is try to ensure that we have available more information and more try to gain this accuracy for all this study that we are doing in climate change. And then the other main point which we are working is try to break the barrier that we have from the typical result that we obtain from the scientists to try to make all this information for the general public. So as you know, we have a lot of limitation at the moment that we are developing our scientific results, which is a summary here about the possible difficulty that we have and the possible solution in which we are working also through project as Destination Earth. So the idea is to create a complete infrastructure to develop these environmental services. So the idea is try to have some use application that immediately can be used for government, for example, for this making decision of the climate change mitigation. And this is something that we are developing, not just very nice words, it's something that we are developing in the context of Destination Earth with the supporting of ESiWACE, no? Try to have all this information in data lakes, user application that can be used immediately by the user to try to interpret not all this information on demand. Actually, we can provide the results in streaming on demand for all the European community. And well, why also is important HPC and why ESiWACE is also supporting this kind of projects. Probably also this information but the computational power that we need to make possible all these things that I was explaining before, ensembles, the streaming of the data, the projection, 100 years of simulation, also is because we have this critical computational power to make this possible. At the end, we need a huge amount of resources, so the CPU hours, the energy consumption, even the quantification of this carbon footprint about what we are doing is important, to make possible all this complex simulation. As you know, at the end, we are just computational fluid dynamics using domain decomposition, parallelization, MPI, OpenMP, moving now to CUDA or OpenACC solution with the GPUs, but it's the same parallelization strategy that we were using in the last 10, 20 years. But this means that this HPC application is super important for all this model that we are using. And also, as you know, in some cases, we are using yet Cartesian structural grids, but part of the Destination Earth projects or the model that we are using in Global Earth System Model are really complex, So this means that to take advantage of the specific hardware that also we are developing as the new RISC-V processor means that we need very novel technologies and approaches to optimize this model and ensure that they are taking advantage of the high performance computing infrastructure coming from the EuroHPC. Also, as you know, we were moving for this hybrid era, at the end was just focusing in the CPU partition plus adding some movement to the GPUs, but now we are in the exascale, I'm coming actually from BSc, which means that we have -1.5, one of the pre-exascale machine. We have also Leonardo in Italy, Lumi in Finland, and the first European exascale machine in Germany, EuroHPC. What we are pursuing with this exascale is not only more multi-core, many-core cluster, but it's also the new heterogeneous computing. So here is going to be really important the co-design solution to ensure that we are exploiting the new processors that are coming. So here we are talking about these fixed accelerators. For example, with the new RISC-V that I was talking before, they are going to have accelerator, for example, the new vectorization part, and it's really important that our application start to be adapting to this new heterogeneous computer. So this means that we need to work together also with the hardware accelerator, with the provider, with the developer or the scientific developer of the application, and then the HPC expert. So this means that all together needs to be working to achieve this new exascale era. Of course, there are some things that we can gain. And obviously, we have new computing elements So it's not only the GPUs anymore. So now we are talking about the FPGAs, the new AI component, not that actually also the TPUs are going to be there and it's going to be fixed in this new accelerator. We start to explore a little bit about the quantum. We have a new machine actually at BSc, and obviously also the new European processor, this RISC-V. We are going to gain more parallelism, more computing power. We are talking now about exaflops, or facilitate this data streaming that I was talking before, because we are talking about moving petabyte of data for this, for example, destination air climate simulation. And then what? The idea is try to ensure that if we are increasing the complexity of our model, I was talking before, this increased resolution, more component, more ensembles, well, we are ready now to facilitate this transition. And then data sets in our field actually is super important. So also it's important now to be ready for this larger data set that we are producing in initiative as Destination Earth. Probably if we are talking about this exascale era, we can, there are three main topics that I could talk. In my case, also coming from my expertise, even in my group or in my department, there are expertise also for the other two. Where we are really focusing is now in modeling and simulation. And in this one, what I know for sure that is really important is the adaptation in short term for the exascale machine. And now we are working on this. We are working for -5, for Leonardo and Lumi. Then ensure that we are supporting this digital twin for to try to use the EuroHPC hardware, that also we are doing this for Lumi and -5 just right now. And obviously, try to pursue the Center of Excellences and try to be ready for the next generation of this Center of Excellences. Then also we are starting to work in medium term for the adaptation of these other hardware technologies. So we are working for the RISC-V in another project, trying to explore also the clouding, or just ensure that we facilitate the idea about the new acceleration, or even just be ready in, probably this is not medium anymore and should be included also in short time, that the AI and GPU transition. To make all this possible for this short, medium term, this is probably the most important projects in which we are working now. So as you know, I am introducing ESiWACE, but also destination is really important. We are involved, and also if you are interested, I know more information. And also the other European digital twin for the ocean, which is EDITO, which is also a really important and ambitious project in which we are working. So now if we are focusing in ESiWACE, this Center of Excellence, to achieve exascale in simulation for weather and climate, this one is not, yeah. So actually this Center of Excellence started 10 years ago now. EuroHPC actually didn't exist at that moment, but the plan was to ensure that all this climate and weather application was ready to achieve this exascale era. So we initiated this Center of Excellences and start to work to facilitate that all the climate and weather modeling center around Europe could be working together with HPC experts, with supercomputer center of BSc, CSC, DKLZ, to facilitate this idea about, okay, you need to move to the next step with your weather and climate application. So let's work together to ensure that this is happening, to exploit the capabilities of the new increasing computational power from the new machines. So we were starting with -3, -4, and now focusing in this -5. Okay. And well, ESiWACE in particular try to ensure this excellence in exascale. It's coordinated by BSc, actually by me, but at the end we are a consortium with 12 partners coming from different countries around Europe. We are finishing at the end of 2026, but actually we are starting to prepare the new generation of the COEs. I was talking before about resolution is one of the main goals that we are pursuing in our Center of Excellence. So if you are moving to these new possibilities, new features that you can achieve with higher resolution, no, but at the end, no, actually the model that technically we were using at the beginning was the lower resolution. No? So how we can facilitate this transition with the new computational power that you need and ensure that you are exploiting the facilities to make this possible, no? This new resolution. But obviously it's not just the resolution. This is just one of the example. But now I will explain you more, the consortium, about what we are doing in ESiWACE. So in this kind of center of excellences, the idea is to have a very multidisciplinary consortium. So actually in this one we have weather and climate modeling centers, no, that we are participating and working together, plus then the high performance computing centers, for example, BSC, CSC and Jülich, but also we try to involve with vendors and also providers. No? We have Atos, we have been collaborating with NVIDIA also outside the consortium, and obviously also we need to build a big pillar around the training, actually collaborating with EuroHPC, which is really important, or just the communication and dissemination of all the activities that we are doing. So yeah, what we are pursuing in ESiWACE is three main goals. The first one is try to transfer and establish knowledge and technology for this efficient scalable simulation. So this is what I was talking before, no? So we have different applications that are technically, the most important around Europe, IFS, NEMO, ICOM, ECR. So in short, that we are facilitating this transition for the exascale era for this application. But then also it's super important to close on common technology gaps. In our field, and probably in any field also in which you are working, it's also important to have different tools that facilitate this HPC transition for the new era. So here, for data, for example, also for domain-specific languages, we need to ensure that we are working in our specific tools. We cannot use just the same tools that other scientific areas are using, or even just the HPC people. So also we have as a main goal to facilitate a complete portfolio about the tools that technically can be served to the complete community. And then, as I said before, it's really important the community pillar. So here we try to be this community hub for training, communication, dissemination for the complete HPC community for weather and climate. To make this possible, in ESiWACE, we have 6 work packages. At the end, we are working in six different topics. And I'm going to explain you now is in more detail what we are doing for these 6 work packages. 6 work packages, but as I said before, we have 2 complete pillars. The technical one with the different development that we have, and then the community one. So at the end, everything is around these 2 pillars. So for the first one, what we are doing now is to create a complete benchmark just to pursuing the goal for the weather and climate community. So as you know, what we are using, for example, to measure the new supercomputer is try to use the impact for this computational power that we have in this supercomputer. Then also it's true that arise other kind of benchmark, to try to also to measure the memory or try to measure something that is like in the middle, between this memory and computing. In weather and climate, what we know for sure that all our models are memory bound. So for example, this kind of impact is not representative for what we are doing in our models, But even the typical one that starting before are not representing correctly what we are doing in our community. So what we are doing in ESiWACE is try to create our benchmark. And this benchmark technically should be representative for vendor, from provider, to test the different supercomputers, the new hardware, and ensure that they are co-designed with us the different applications. And this is where we are starting to develop the HPC-BB. So this is the benchmark that we have for our complete community. This is open access and is totally available for whoever want to use this benchmarking for testing, for example, the supercomputing that you have. So the idea behind this benchmark is try to ensure the reproducibility using real models that are representing Europe. So we have the real benchmark with the different application from our topic. Then we are including also a specific input for the test cases, so everything is going to be reproducible and directly to be used for whoever is using the benchmarking. Then also we have also including the complete verification with also numerical error checking inside the benchmark and also some metrics. So the idea is that you can also evaluate from the accuracy or the computational efficiency the benchmark directly. So you don't need to have external metrics or profiler to evaluate also this benchmark. Actually, no. How we ensure that we are not just adding a new layer with another benchmark? The idea is we are integrating in this HPCWB real weather or climate application. No, maybe not the biggest model, but at least partially, no, one of these applications that we are using. So this means that also we are including the framework, no, around the model, no, to facilitate, for example, the deployment with all the dependencies that we have in the benchmarking, and also producing the same result that you can obtain with real models and report all these results. Also, the idea about this benchmarking is try to be agnostic, no? So technically to maintain, to create this easy build, we are including different packages that can facilitate the model build system, the cluster environment, the scheduler system. So independently of the machine or the configuration, SLAM, scheduler, whatever that you are using, technically the HPCWB will be adapted to your environment. And then obviously, no, it's not just a matter of run something in particular, but should be something custom referable. So this means that there are different use cases and you can adapt and try to change, no, the parameter that you are using in your case. Maybe I not needed to stack in detail of this, but to facilitate all this for the deployment, compilation, and running, we are based in CMake for the compilation, and then also SPAC recipes to ensure, no, but it's optional, but probably recommended, no, to facilitate that the deployment of the model is something easy for the different scientific users who want to use it, no? So we have this CMake and SPAC. This is an overview about actually the details about the HPCWB. So this means that we have real models, no, inside the HPCWB, and again this is open, free, and accessible through the ESiWACE webpage. Then also we have Dwarf, which is like toy model based on the real model, no, for example AFS, but it's more simple, no, to run. And then also we proven to be available for different machines. For example, it's available in Mare Nostrum, Lumi, or also the Jupyter machines. HPCWB was developed in different projects from some time ago, so actually starting 10 years ago, but now is included in ESiWACE, and we are also facilitating the transition for the new generation. And something good here is not just an European benchmark anymore. So actually, we are starting also the collaboration with other European project, but also there is a counterpart in Japan and India, and we are starting this more international collaboration. So what we are doing in ESiWACE now has some continuity and expanding through Japanese and Indian collaborators. So this means that also we are including one Japan model and one India model. Actually, it's based in Wolf, no? That I know that some people here actually is working in using this model. So this means that actually HPCWB is open to add new benchmarking that could be representative for you and ensure that also is working in different EuroHPC, but now also Japanese, India machine or whatever that is coming in the future, no? Because the idea is try to ensure that beyond this 2027, we are increasing, no, the possibility with this HPC-BB. I was talking a lot about the HPC-BB, but obviously the benchmark itself is not the goal. The goal is try to facilitate the co-design for the weather and climate application. So this means that we are supporting and pushing this HPC-BB, for example, for different initiatives for the post-exascale era. So we are collaborating with the European Commission to ensure that this HPC-BB is used for the co-design of the new processor, for example, the RISC-V, but also the novel technology, the novel hardware that is going to come in the next 10 years. So we are working in these support activities to ensure that HPC-BB is the real benchmarking that is representing the climate and weather community. So moving now for the World Package 2, is more related with these common technology gaps that we need to solve for the weather and climate community. And in particular, we are working in these tools. No? We are working in tools to reduce the numerical precision, also domain-specific languages, that the idea behind this is try to facilitate the portability from whatever that you are describing for the equation that you are working from the domain perspective to the specific supercomputer that you are using. So the domain-specific language try to facilitate the transition from just describing the equation or solving the equation to the new GPU partition that you want to exploit. No? So domain-specific language try to facilitate all this work. And then also we are working in tools for the automatic computational performance and energy analysis. These tools are not actually just for weather and climate application, but are tools that can be deployed in your machine, in your supercomputer, and try to provide you all this information to find new bottlenecks, to ensure that your model is or not efficiency enough from the energy or even the carbon footprint perspective, and to provide you a lot of information about what is happening. The goal about this kind of tools is try to facilitate you the monitoring of the activity that you are doing, no? Apart from the typical speed up, CPU hours, simulation just per day that technically we are using now from the climate and weather community. About this one, I will tell you more, but at the end, all these tools that are summarizing here, we have a portfolio. All these tools are open access and free, also in our webpage, and they can be used with test cases, also with examples for any of you. So all these tools are there and can be accessed for everyone there. Then about the data. Also, I learned from you this morning that all the data and post-processing, summarization, working with the necessary formats and the transition, no, from the data that we are producing in the simulation to the real data that is used for the scientifics is also important. No? So what we are doing in ESiWACE is also try to facilitate this data challenge. And what we are doing? Well, we have a lot of data. We are working with this global system model. Probably this is a Diogenes syndrome, but well, we need to live with this amount of data. So what we are doing here is develop an online compression laboratory, which is again available for free for the complete community. So so the idea behind this one is obviously, if you need to store your data, at least try to reduce the cost about this data that you are saving now for then the analysis. So this means that we are developing this lab to make possible the compression of all this data without losing the accuracy of the result that technically you are obtaining. Or even if you are going for lossy compression, at least to ensure that the digits that you are reducing is not affecting for real the accuracy of this simulation that you are doing. This data lab compression, is a very simple way to test what we are doing in ESiWACE. So this means that actually it can be downloaded directly from the QR. is including different algorithms as a complete portfolio to facilitate this compression of the result that you have. Everything is explained there. So in this online laboratory data compression, you have different documentation explaining also how to use the Jupyter Lab and try to facilitate that you are using your real data to use the Python tool that we have in this lab and start to compress the information that is there. Also, there are use cases with the real data to show how this works. So yeah, it's easy to pick and go. There is not installation needed. And it's just open the website and try to facilitate this interactive way to use the information. Obviously, what we have in the interactive way using Python is slower, that maybe you are expecting from the approaches that you are using. But if you are more interested in this one, also we can facilitate the native tool for the HPC, for the supercomputer, that obviously is going to gain a lot in performance. At the end, the idea is try to convince you about using this fairless lossy compression and install the real one by yourself and try to test the possibility that this compression lab can offer to you. Well, the idea is not try to be used but just the community that we are, for example, supporting in ESiWACE, but try to be used in a portable way for everyone. So also we have a container using the Jupyter Lab that can be pre-installed in any machine that you can imagine for to exploit this possibility. So easy for sharing. We have different code example or experiment based in this model that I was talking before to use all this information. So this is for the data. We are moving now for the community pillar. So here we have services as a first step. So in this one, so this is a video technically trying to explain the compute services, but obviously I'm not going to. So yeah, in this work package, the idea, I'm not going to put the video and anything, And the idea of this one is try to have open calls for free for everyone who want to apply for the services. So this means that if you have different applications related with the weather and climate, so weather and climate application, you can apply for this kind of services. The idea is try to have everything. So for example, we can facilitate the porting of this weather and climate application for the EuroHPC infrastructure. We can work also to facilitate the tools that we are working. So we can work in containerization. We can use our tools to reduce this from double to single precision, this mixed precision, the variable that you are using. Or we can just work in optimization. So this means to speed up the throughput of your models. The idea behind this kind of services is work with you. So this means that you are applying for the call, but then we are working with the real developer to ensure that we are not changing, for example, the understanding of the code. For example, for GPU porting, we are providing the optimization for the GPU porting, but in collaboration always with the weather, with the developer of this weather and climate application. I have also some examples. Yeah. So the idea about these calls is, on the one hand, is directly model optimization acceleration of your application. Here, we can be dedicated 6 months to work in your application. Then also, well, in this one in particular, we have different examples. This is real example in which we has been working the last period of time, so the last year. So, for example, for the ESM tool, we were working to improve the computational performance of these performance or validation tools, increasing the parallelization and ensuring that it's working in EuroHPC machine. Also for ECR4, we were working to reduce the precision of the ocean model. So here we were reducing from double to single precision 90% of the variable, and it was improving 35% the speed up of the model. Then also in more traditional way, we were working for Globo, working on doing profiling and optimization in MPI communication, trying to reduce the I/O part of the, we using the I/O servers and clients perspective. We were also facilitating this I/O throughput and ensure that the server was working in a proper way. Or also we were doing in GPU porting. So CAMP was they applied from one university to ensure that the chemistry module was moving for this new GPU porting, and we were working to facilitate the new porting solution to the GPU, and actually speed up the model. I think was like 70%. Also we are working now in new porting services. So the previous one, this 4, was in the last period, and now we are working in a new core, and theirs is one of the models that we are working. So for example, in this one also we were facilitating the GPU porting, increasing the speed up 20%. Obviously this means that you are saving a lot of energy, or also increasing the idea about use the supercomputer that you are using, and try to facilitate the transition for new EuroHPC machines. In this Globo, the idea was to improve this MPI communication and the I/O, what means also increase at the end also the speed up, because if you are increasing the I/O part of the model itself, also you are increasing the throughput of the real model. And in this model card that I was talking before, actually the speed up was bigger than I was saying before, So just for the chemistry module, this new GPU porting solution increased 70% the speed up, that at the end translate to the 3.5 faster the complete model, So including also now the CPU part that is there in these chemistry components, but just with the new GPU solution was increasing almost 4 times, the speed up of the compute model. Apart from these services that I was talking before, the idea is also try to provide to the community services for the tools that we are developing. So this means that it's not only supporting the specific application that you have, it's also facilitating that you use all the tools that we have. So here we also provide 2 months supporting you to ensure that, for example, you are using directly this tool that we have to reduce the precision, or try to make available the data compression lab that I was talking before, or just ensure that whatever of the tool that we are providing are able and ready to be used in the supercomputer that you have. Then also we have this training and in general, different activities that we have around the idea of facilitating new HPC experts to work in weather and climate application. So here we are organizing for free, this hackathon, summer school, or just online courses, actually in collaboration with the EuroHPC partner. We have 2 previous hackathons before in October and June. The idea was focusing in some specific application that you have and try to facilitate, for example, the porting or deployment in Lumi, in Mare Nostrum 5, or other machines. Now also, the last year and the last summer, we have a summer school. So here was in collaboration with other scientific project with One World, and were coming expert or student from all around Europe, and again, try to gain some knowledge about activities in which we are working for the community. We are also organizing training events virtually. Actually, this one in collaboration with NCC or the EuroHPC, so they are EuroHPC seminar. We are doing this for the different tools that also we provide support. So for example, this Xtray and Paravel are BSC tools that I use for the profiling analysis. So VanPy, Intel VTune. So if you know about these specific tools, X-ray and Parabel are the one that we are providing support in ESiWACE or directly by BSc, and other, for example, POP, this transversal COE also provides support for this X-ray and Parabel. But in our case, very focusing in the weather and climate models. But we have more, no? So for example, we have specifically focusing in weather and climate application for GPU optimization. We have also the Kellner tunnel, which is a very complete tool to understand what is happening and try to provide more metrics about all the possible applications that you have using GPUs. We were organizing different seminars. All this training material is available for the community also in our webpage, and we are organizing, or actually interested in organizing, more seminars or more training following this line. And well, so some of the statistics that we have, that I think we are really happy, just having more than 100 attendees for this kind of events. Also, for your information, we have a new hackathon, which is going to happen in October. The call is yet open, so this means that you can participate in the hackathon. In this case, is try to facilitate the deployment adaptation for the new exascale machine for Jupyter. So if you in Jülich, so if you are interested in, actually also is important. The previous one were just physical meetings, but now also it's possible the hybrid format. So if you want to participate, you think that you have an application that you want to move or try to be ready for the new machine in Jülich, well, this could be your opportunity. Why this could be useful for you? Imagine that also you are applying for EuroHPC resources, no? So in this case, if you say from the beginning that you did the deployment and was working, the application that you are using this hackathon, well, probably you have more opportunity, to get funding with this EuroHPC course that are open from time to time. Also, we have a new summer school, which is going to be also closed, in this summer, but again, yet is open, So if you are thinking about the students or PhD student, postdocs, that could be interesting, to know more about this weather and climate application that we are supporting. Also, this summer school is there. And well, I think also this place in summer is yet a very nice place. And finally, also we have the communication work package. In this one, we try to ensure that we have the connection between the domain expert that we have, the HPC expert that we have, to the general user or just all people that can or would like to know more about what we are doing. So here, we try to build this complete network, also actually in collaboration with the EuroCC or the NCCs, and ensure that we are moving and try to participate in different European initiatives. Here we have plenty of dissemination activities. Actually, one of these is what we are doing now, and ensure that we are as a Center of Excellence, we try to be very active, and it's really important also for us to participate in all these kind of events. We are involved, we are trying to participate in the domain scientific event, but also in the HPC event, For example, the ISC that was happening 1 month ago. And well, also it's not only the dissemination activities I was doing before, but also we organize workshop, or we try to participate in workshop with other projects or just other initiatives. So we were in the IPAC organizing one of the sessions. We organize this workshop from time to time, the NS, the European Network Infrastructure, or try to participate with other Center of Excellences in other events or workshops that they are organizing. So also with EuroHPC, also we are really happy to participate and collaborate in other kind of events. And this is just some example, So for example, following this EuroHPC, we were together with CIS, which is the other Center of Excellence for Urgent Computing, collaborating together. Or actually, we also collaborate directly with the World Climate Research Program. In this case, also facilitate some work for the monitoring of energy and carbon footprint reduction for our climate application for CMIP, or just a center of excellence, no, moving for different activity with Castiel, no, which is trying to connect or try to be this networking for both, no, the center of excellences, NCCs, or whoever participating in the different domain for the EuroHPC. So at the end, what we have with ESiWACE is not only the consortium that we have, but also is the framework that we use to connect the models and tools that we have in our weather and climate community with all the HPC community, because it's not only BSc or CSC, but at the end, it's also try to ensure that we are connecting with the most relevant HPC project around the world. So also this means Epicure, which is, for supporting the EuroHPC infrastructure. We are also collaborating with their project, which is focusing in this developing of the new RISC-V professor. And finally, also connecting with the Earth System Model community. So here is the rest of this scientific project, this Japan or India project that I was talking before, but and destination, obviously, which is one of the most important for the future with the digital twins. So ESiWACE try to be involved in all of them at the same time and try to connect these models, HPC community and the Earth System Model community. And as part of also of the activities, in the community engagement, also we are trying to promote the gender equity and organizing some specific events, also addressing for women in HPC. In the last year, actually, I think that has been increasing a lot, and actually more and more women are participating in our activities, not only as user or student. We are talking about also inside the consortium, and obviously also actually the person leading the world packaging community is Rosa Rodriguez, and the idea here is also to promote different activities that can engage in HPC more women. And just to finalize, obviously we are also involved in the social media. We have different channels where you can find us. If you are interested to know more, we have this ESiWACE webpage I was talking before, but we have different channels and you can reach us using any of the channels that you would prefer. And that's all. I don't know if it has been too much or not, or too less. It's fine, no? Yeah. So thank you for listening to me.
Right.